preparation of alkenes. That is dehydrohalogenation of alkyl halides. Second method, dehydrohalogenation. Dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. So many terms are here. Dehydrohalogenation and alkyl halide. We know what are alkyl halides. Alkyl halides are the monohalogen compounds, monohalogen derivatives of alkanes. That means from the alkane molecule, one hydrogen atom is replaced by a halogen atom, for example, chlorine, bromine, etc. CH3Br, C2H5Cl, C3H7I, etc. All these are examples for alkyl halides or monohaloalkanes. So, alkyl halides are formed by the replacement of one hydrogen atom, just one hydrogen atom, by a halogen atom. Then dehydrohalogenation. What is meant by dehydrohalogenation? Hydrohalide. What is hydrohalide? We can write hydrohalide as HX. Hydrohalide. Say, for example, HCl, HBr, HI, etc. Hydrogen chloride, hydrogen bromide, hydrogen iodide. In general, hydrogen halide. Hydrogen halide. Now, what is dehydrohalogenation? So all these are hydrohalides. Hydrochloride or hydrogen chloride, hydrobromide, hydrogen bromide, hydrogen iodide, or in general, HX, hydrogen halide. And what is dehydrohalogenation? Dehydrohalogenation. What is the meaning of DED? D means minus, removal. So, minus HX. Minus HX. That is a dehydrohalogenation. If you add HX, then it is hydrohalogenation. Hydrohalogenation. If you remove HX, that is a dehydrohalogenation. If you add water, then it is hydration. If you remove water, then it is a dehydration. Hydration, dehydration. Hydrogenation, dehydrogenation. Similarly, hydrohalogenation, dehydrohalogenation. That means removal of HX. That is called a dehydrohalogenation. And for the dehydrohalogenation, what we have to do? We have to heat alkyl halide with alcoholic potassium hydroxide. Say alkyl halide is heated with alcoholic potassium hydroxide KOH. Alcoholic potassium hydroxide. The medium is alcoholic. Instead of water, we use alcohol as the solvent. So it is called alcoholic KOH. If water is the solvent, then it is aqueous KOH. Aqueous in water, alcoholic in alcohol, ammoniacal in liquid ammonia. Ammonia. So here we take alkyl halide. and it is heated with alcoholic KOH. Then there is removal of HX, hydro dehydrohalogenation minus HX, dehydrohalogenation minus HX. Then we get alkene, alkene, and this reaction is called dehydrohalogenation of alkyl halide. So removal of HX, that is a hydrogen halide from alkyl halide by heating with alcoholic KOH. The reaction is called dehydrohalogenation. Dehydrohalogenation. For example, alkyl halide is heated with alcoholic KOH. We get alkene as the organic product. Let us take one example for this reaction. CH3, CH2, then Br, and this is a bromoethane. The compound is bromo bromoethane. That is the IUPAC name. Or we can call it as ethyl bromide. Ethyl, alkyl, ethyl bromide. Ethyl bromide. Say the alkyl halide taken here is ethyl bromide or bromoethane, and that is the IUPAC name. The IUPAC name of this compound is bromoethane. There are two carbon atoms, ethane, and there is bromine atom on the carbon atom of ethane, and so it is bromoethane, IUPAC name. And in the common system, it's called ethyl bromide, CH3CH2. That is a ethyl group. Ethyl. Similarly, CH3 methyl. All these groups are generally known as alkyl groups. We have seen that. So ethyl bromide or a bromoethane, and this is heated with a alcoholic KOH. Alcoholic KOH. Then what happens? That is dehydrohalogenation. Dehydrohalogenation. The halogen here is bromine. So minus HBr. There is a elimination of a HBr. Dehydrohalogenation, dehydrobromination. There is a removal of HBr. And then we get CH2, double bond CH2, ethene, alkene, ethene or ethylene is formed. During this reaction, the dehydrohalogenation of ethyl bromide, there is a elimination of HBr. When HBr is eliminated, the hydrogen is removed from the beta carbon. So another term comes here. See, the carbon atom bearing the functional group, that is called the alpha carbon. Here the functional group is bromine atom, bromine. So the carbon atom bearing the functional group, namely bromine, it is the alpha carbon. The next neighbor, that is beta. If there is another one next, then it is gamma, delta, epsilon, etc. So all these terms are necessary. So the carbon atom to which the functional group is directly linked, the functional group, here it is bromine, directly linked, that is called alpha carbon. The next one, beta carbon. The hydrogen atoms on alpha carbon, they are called alpha hydrogens. Hydrogen atoms on the beta carbon are called beta hydrogens. I shall repeat this. alpha, beta, gamma, etc. Regarding these positions, the carbon atom bearing the functional group is called alpha carbon, or the carbon atom to which the functional group is directly attached, that is a alpha carbon. The next neighbor is a beta carbon. The next one is a gamma carbon. The next one is a alpha carbon. The next one is a beta carbon. The next one is a gamma carbon. So the carbon atom bearing the functional group is called alpha So let me continue with the alpha, beta, and gamma carbon atoms, alpha, beta, gamma hydrogens also. Okay, we must know what are alpha, beta, gamma hydrogens, alpha, beta, gamma carbons also. Let me mention about that. Say, for example, you take CH3, CH2, 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 CX, a compound like this. Here, the functional group is X. That is the functional group. The carbon atom bearing the functional group, that is called alpha carbon. The hydrogen atoms on alpha carbon are alpha hydrogens. So to have alpha hydrogens, first of all, there should be alpha carbon. There should be alpha carbon. The hydrogens seen on the alpha carbon are alpha hydrogens. The next one is beta. Next carbon is beta. And the hydrogen atoms are beta hydrogens. Then gamma, delta, epsilon. These are the various names given. Usually, we need only these two, alpha and beta. We need only alpha and beta. So you concentrate on alpha and beta. So what is alpha carbon? The carbon atom bearing the functional group, that is alpha carbon. The hydrogen atoms on alpha carbon, they are alpha hydrogens. Then the next neighbor, that is beta carbon. The hydrogens on the beta carbon are beta hydrogens. Do you get this? If it is so, Achyut, let me ask me a question. Say you are given a compound like this. Say CH C double bond OH. You are given a compound like this. It's an aldehyde. And that compound is methanol. That is a methanol. It is also known as form aldehyde. Yeah, you have to study this next year. Okay. So the functional group is a CHO group, aldehyde group, aldehyde group. Now my question is this: how many alpha hydrogens are there in methanol? Achyut,
One, sir.
one. What is alpha hydrogen? Adul is staring at me. Okay. So what is alpha? What is alpha hydrogen? Come on, try.
The hydrogen
Or
atom
hydrogen or
uh, close to the like carbon atom.
hydrogen on alpha carbon. Hydrogen on alpha carbon. That is alpha hydrogen. And what is alpha carbon? The carbon atom bearing the functional group. The carbon atom bearing the functional group. That is alpha carbon. You must be thorough with this. Otherwise, you will be confused next year. Okay. Here, the functional group is a CHO group. Aldehyde group. Aldehyde group is the functional group. Functional group. Okay. The carbon atom bearing the functional group. That is alpha carbon. How many alpha carbons are there here? Tell me. Is there any alpha carbon in this compound? Is there any alpha carbon in this compound? Okay, Achyut. CHO group is, yes, listen. CHO group is the functional group. Agreed? Aldehyde group. Aldehyde group. That is the functional group. Okay. Then the carbon atom to which the functional group is directly linked. That is alpha carbon. Now you say whether there is any alpha carbon or not in this.
No, sir.
There is no alpha carbon. If there is no alpha carbon, then how can there be alpha hydrogen? What is alpha hydrogen? What is alpha hydrogen? Hydrogen on alpha carbon. Atul, Adna, Krishna, do you hear me? So the hydrogen, Vidur, Rajas, the hydrogen on alpha carbon is alpha hydrogen. See here, the hydrogen atom is directly linked to the functional group. Here there is no alpha carbon at all. If there is no alpha carbon, there is no alpha hydrogen. So the hydrogen here, that is your confusion. The hydrogen here, this one, this is not alpha hydrogen. That is not alpha hydrogen. So that compound lacks, that compound methanol lacks alpha hydrogen. It lacks alpha hydrogen. Okay. It lacks alpha hydrogen. But you come to the example given here, shown here. Say the example shown. You take the example shown here. In that there is a alpha carbon. Say in the example I have cited, there is a alpha carbon, and therefore there are alpha hydrogens also. Agreed? See, this is our alpha carbon. And so here there are alpha hydrogens. In that compound, in the given compound, there are alpha hydrogens. Agreed? Similarly, here there are beta hydrogens also, because there is beta carbon. And on the beta carbon, there is hydrogen. And that hydrogen is beta hydrogen. All right. So I agreed this, alpha and beta. You make it sure. Eh? The carbon atom bearing the functional group, maybe aldehyde group, maybe carboxyl group, maybe a NO2 group, maybe halogen atom, chlorine, bromine, whichever functional group is there. The carbon atom bearing the functional group, that is alpha carbon. And hydrogen on the alpha carbon, that is alpha hydrogen. So in the compound methanol, there is no alpha carbon at all. So there is no alpha hydrogen. So the hydrogen is not alpha hydrogen in methanol. But in this compound, I have written here, There is a alpha hydrogen. Similarly, there is a beta hydrogen also. Okay. So remember these two terms, alpha and beta. Now let us go back to the example given for the production of alkene. The example given was CH3, CH2, Br, CH3, CH2, Br. That was the example given to you. And this compound is in the IUPAC system. The compound is bromo, that is bromoethane, bromoethane. And in the common system, it is ethyl bromide. Ethyl bromide, alkyl halide, ethyl bromide. Okay. And this is heated with alcoholic KOH. Then there is removal of HBr and we get CH2, double bond CH2, and it is our ethene. That was the example taken. All right. During the elimination of HBr, during the elimination of HBr, which hydrogen is removed? Which hydrogen? See, here the functional group is the bromine atom. Bromine atom. So the carbon bearing the bromine atom, that is alpha carbon. Okay. Then the next carbon is a beta carbon. Beta carbon. Here, during the elimination of HBr, in general HX, the beta hydrogen is removed. See, compare the reactant and product. Compare the reactant and product. In the product, CH2 is retained. And another CH2 has come, and it is from the CH3 group. That means hydrogen is eliminated from beta carbon. Or you can say beta carbon is eliminated. So remember, during the elimination of HBr, the beta hydrogen is eliminated. Eliminated. Beta hydrogen is eliminated. There is beta carbon and there is beta hydrogen also. Beta hydrogen also. The beta hydrogen is eliminated. And so, this reaction is called the beta elimination reaction. Beta elimination reaction. Beta elimination reaction. The removal of a beta hydrogen, the removal of a beta hydrogen, that is called beta elimination. Here, the beta hydrogen is removed as HBr. Sometimes beta hydrogen will be eliminated as water, H2O. Okay, we'll see next year. So, elimination of a beta hydrogen, that is called a beta elimination reaction. So, here there is a beta elimination reaction. And for beta elimination, the reactant used is usually alcoholic KOH, not aqueous, not in water, but in alcohol. Solvent is alcohol. There is a elimination of a beta hydrogen as HBr minus HBr. And so the reaction is called a beta elimination reaction. Agreed? You follow this? We need this for the second year, beta elimination
Yes,
reaction.
sir.
It is highly necessary for the second year, beta elimination. So, first of all, there should be beta carbon. Secondly, the hydrogen should be there on the beta carbon. That is a beta hydrogen. And that hydrogen is to be removed. Then it is called the beta elimination. So by the beta elimination of alkyl halide, by heating with alcoholic KOH, we'll get alkene. For example, ethyl bromide or bromoethane when heated with alcoholic KOH. There is a beta elimination. Beta hydrogen is eliminated as HBr minus HBr. Then we get the product as ethylene. Let me show the reaction like this. CH2H, then CH2Br, CH2Br, and there is elimination of HBr. See, that is the reaction. Beta hydrogen. Say this is alpha. This carbon is alpha. This is beta. So beta hydrogen is eliminated. Okay. So there is a beta elimination reaction with the formation of alcohol. I mean alkane. We have to see one more reaction for the production of alkanes. And it is the acidic dehydration of alcohols. The third method. Third method. Acidic dehydration. Dehydration of alcohols. Dehydration of alcohols. Acidic dehydration of alcohols. What is dehydration? Dehydration. Hydration plus water. Addition of water. Hydration. What is dehydration? Removal of water. Removal of water. That is dehydration. And what is acidic dehydration? That is removal of water. Removal of water in presence of an acid. Acid is the dehydrating agent. There is a removal of water, and to remove water, we need a dehydrating agent. You have studied this in the 10th standard. Any substance that can remove water, that is called a dehydrating agent. So here, the dehydrating agent is an acid, for example, concentrated sulfuric acid. So we can say when alcohols are heated with concentrated sulfuric acid, there is a dehydration, removal of water with the formation of alkenes. Let us take one example. CH3, CH2OH. An alcohol, the functional group is a OH group. And this alcohol is ethanol, ethanol, ethanol. That is the UPSC name. And the common name is ethyl alcohol. Ethyl alcohol heated with concentrated sulfuric acid. Excess of a concentrated sulfuric acid. High temperature. Then there is removal of water. Dehydration. Minus CH2O. We get a CH2, double bond CH2, and it is our ethene. It is alkene. Let us think of the elimination of water. Say, show structure. I shall show the structure of ethanol like this. CH2, there is H, then CH2, CH2OH. Same thing, CH3, CH2OH. And it is heated with a concentrated sulfuric acid. There is a dehydration. There is a elimination of water. Say elimination of water like this. So minus H2O, minus H2O. And we get CH2, double bond CH2. Okay. So during the elimination of water, so which hydrogen is removed? OH is removed. Along with that, OH is the functional group here. In the alcohol, the functional group is OH group. OH group. And during elimination of water, which hydrogen is removed? Yeah, come to alpha beta. Come to alpha beta. So which hydrogen is eliminated? It is removed. The carbon atom bearing the OH group, that is alpha. Next one is beta. So this is alpha and this is beta. So which hydrogen is removed? Come on. Atul,
Beta hydrogen.
beta, hyd- beta hydrogen is removed. This is also an example for beta elimination reaction. Just now I told you there may be elimination of water also. This is also a type of a beta elimination reaction. So by the dehydration of alcohols with concentrated sulfuric acid as the dehydrating agent. Dehydrating agent, say alkenes can be prepared. That is the third method. We have taken only three methods. So try to remember these three methods, especially the beta elimination reaction. Beta elimination reaction that is highly needed for the second year. Beta elimination of the alkyl halides or a beta elimination of alcohols. Dehydrohalogenation of alkyl halides or dehydration of alcohols. All these two are examples for the beta elimination reaction. Okay. Now let us see the properties of alkanes. I'm more interested in the chemical properties of alkanes, not much about the physical properties. The lower members are in the gaseous state, higher members in the liquid or usually in the liquid state. Then they are immiscible with water or they have a low boiling point, melting. All these things are there. So, but let us think of some chemical properties, important chemical properties of alkanes. So, let me take the chemical properties, the properties of alkanes. Properties. Usually, I take the chemical properties of alkanes. As we have seen, alkanes contain carbon-carbon double bond, and so they are highly reactive. They are highly reactive compounds. Here also, the alkanes can react with the HX, can react with the H2O, can react with the Bayer's reagent, can react with ozone, etc. Let us begin with the addition with the HX. The first reaction, addition with the HX. Addition with the HX. HX. HX means HCl, HBr, and HI. HCl, HBr, and HI. HX. Let us see the addition reaction. What is addition? Addition is the combination of two or more molecules forming a single product. Some kind of combination reaction. You have studied a combination reaction at 10th standard. Similarly, here also, so this is also a type of combination reaction. A single product is formed by the combination of two or more molecules of the same type or different types. That's called the addition reaction. Okay, you take a say reaction between ethane CH2 double bond CH2 plus HBr addition of a HBr. HX in general. Let me take the addition of a HBr. Then the pi bond is broken. CH2 single bond CH2 pi bond is broken and HBr is added. The molecule added is called the addendum. Addendum. The molecule added is called addendum. addendum. HBr here is the addendum. It is a addendum. Addendum. The molecule added is called addendum. So HBr is the addendum. So the addendum splits into two parts. Here H plus and Br minus. And there is addition of a H and Br. So the compound is CH3, CH2, Br. That is bromoethane or ethyl bromide. Bromoethane or ethyl bromide. Okay, bromoethane or ethyl bromide. CH3 CH2 group is called the ethyl group. So ethyl bromide is obtained or bromoethane is obtained. Say pi bond is broken, hydrogen is added to one carbon and bromine is added to the other carbon. Okay. You take another example. Say, take the propene molecule CH3, CH double bond CH2. It is our propene molecule, propene. And to this, we are going to add HBr, and which will be the product obtained. During the addition of HBr, addendum HBr, the pi bond is broken and one part of the addendum is added to one carbon, the remaining part of the addendum is added to the other carbon. Okay, let me take, say, the mechanism CH3, CH, single bond CH2. Now the pi bond is broken. Okay. So which carbon you are going to add H and to which carbon you are going to add Br? There is problem. There is problem. Say, suppose one is adding H to this one and Br to this one. So the compound is CH3, CH2, CH3, CH2, CH2Br. Or if somebody is adding, say, hydrogen to the other carbon, CH, single bond CH2, pi bond is broken, and if I'm adding H to this and Br to this, so we can expect two compounds here. One is 1-bromopropane and other is 2-bromopropane, and which is the major product. Which is the major product. We have to decide which is the major product. And to decide which is the major product, we must know another rule. Another rule. And the rule is called Markovnikov's rule. Markovnikov. Markovnikov or Markovnikov. Markovnikov or Markovnikov. Regarding the spelling, Markovnikov, Markovnikov, or Markow, Nikov, there will be a difference in the spelling. That is a Russian name. Russian name. So there will be Gorbachev, Gorbachev. You don't know who Gorbachev was. Okay. So regarding the names and the spelling, there will be slight difference. Okay. Kozhikode. How will you write? Any Kunjuni is here? What is your spelling, Kunjuni? Kunni or Kunji? Problem arises. No. Similarly here also. Don't worry about that. So Markovnikov rule. So Markovnikov rule will help us to decide which is the major product obtained. So we must know what is a Markovnikov rule. And only after that, we can decide which is the major product obtained. That rule we can discuss in the coming class. For the time being, let me stop. Thank you.